soon as possible.
Hello.
Hello, good morning, all.
Yeah, good morning.
How to get the most of it.
Morning.
Please, has the lecture begun? I can't hear anything.
No?
Get started.
Hello, how are you?
We are fine. We are waiting to start.
Hello? Hello? Hello, good morning all.
Hello, good morning, all. We've been
Good
waiting.
morning. Yeah, we're just waiting. We're just giving time for some people so that we can admit them. That's why.
Okay,
Let's just wait for
thank you.
3 minutes time or 5 minutes time so that we also admit more people. Before I proceed. So, good morning all. Good morning.
Good morning.
Yeah. So let's just proceed now. So anybody that comes in will join us from here. we're starting from where we're starting from. So last week let me just do a recap of what we did last week. So throughout last week we were able to go through the theoretical aspect of road design and all. We will talk, discuss more on the highway manual, and I expect most of us must have gone through the manual and see details. Learn and how will I call it, and research more and get to know more about the codes and its application on road design. So basically today now I'll be starting from where I stopped last week, which was the point importation. So I would also do a recap of what we did last week. Last week, what we did was we imported points and we went through a series of, how would I call it, challenges and problems you might encounter when you're importing your points, which I highlighted I encountered 3 challenges when you're importing your points, which are when the survey data is having a header title, when the survey data is what I call it, when there's a comma sign on the survey data, and when the Excel workbook is open, which I highlighted last week. And as well, we talked on the format. You save your work. You save the work in a CSV format, limited format. Then after that, we talked about the various formats which the software, which you can import the Excel workbook into the software. These include the PNZ, PNEZD, which we discussed in extension last week. The point number, the east name, the north name, the elevation, and the description, the raw description. So, I will go through the point importation again from there now today. So I will go through the point importation, which is the first item on the script. Which is the first item here. Then after the point now, the next one is surface. Those should just show a recap of what we did in the next 2 weeks. So after you have imported your point, then you create your surface. So after the surface, now the next thing is alignment. That is the horizontal alignment of the road. So after you're done with the alignment, the next thing is the profile. It's called profile. When you research, the profile is the vertical alignment of the road, where you do your design formation level of the road. That is your cut and fill, the vertical alignment. So after this, we'll now do assembly. This now proceeds us into doing our cross-section design. Cross-section, we'll do a typical assembly of the road, then we'll apply. Then from there, we'll create a corridor of the road corridor, using assembly to build across the corridor of the road. So after this, the next one, we'll create a corridor surface. This corridor surface now enables us to do our actual computation for our cut and fill for the road. So after the corridor surface, they will do sample lines. So this sample line is cut at what sample line does is cut it at every section at 25 meter interval or 20 meter interval to create a sample line for you. And from there, you now produce your cross-sectional drawings, which is the last aspect of the road design. So after this, the next one is you can go to pipe network, design your storm and sewer line, certain civil 3D as well. So basically today now, let's go through what we did last week, which was the point importation. Which was point importation. So we go through the point as well again. So let's just like this, what we did last week. I will take off the header here. Select Control A, Control C, Control N, then Control V. So I will now take off the header, delete this. Then I'll now go to File, and I'll save as, and I'll save as on my desktop. My save as type now will be in CSV, delimited, and I'll give it a name. Go and save it on my desktop. And then it's TROD2. TROD2. Day 2. So I'll click save. So once I've saved now, from here, I will now ensure the workbook is closed, just like I highlighted last week, I stated last week. So I'll close this now. I'll minimize, and I'm now going to go to the software. So just like I stated last week, that we can import our points using 3 different formats. The major and to put the emphasis is I'll be looking for the name points, which I have one here, points, and I have points, and points. Points. So this one is the menu bar. So if parameter is not showing on your own now, you see it's showing hide menu bar here. If I click hide menu bar, it goes off. But parameter is showing like this, then you can bring it up back, click here and say show menu bar, which I stated last week. So we'll go to points. So I'll click on import points. So for the point importation now, I'll select the plus sign here. And then I'll look for where my point is being stored. Like I said last week, if you're using it for the first time, this file type here will be showing all files. It will be showing all 5 here. So you just have to come back to this file type and change it to CSV. All the whole expression file having CSV attached to it. You can see them here on my desktop. So I'll select this one. And I'll click open. Once it's done, then the next point of call now, I will not select the format in which the data has been saved in the Excel workbook. So this is the format. So this is the format in which the workbook is being saved. So the format is PENZD. As well, last week I highlighted on this aspect of listing and noting that we have to be conversant of which ones comes first. So we know the format we are bringing it to match with the format we are bringing it to match with the format that we have on the software. So you have to be conversant of which one the surveyor interchange on the row first. So for the listing, last week is normally lower. The value is normally lower compared to the nothing has a higher value compared to the listing value. So those are the things you'll be checking out for these 2. Which one comes first? So you select the format in which the work is being saved, just like I highlighted last week. So this is depends based on the work I'm working now. So you can see the various format we have there as well. You can see this one now is showing that the nothing now comes before the listing. So we have to be conversant of which one comes before the other. So this one now, based on the workbook, the data I'm using now, the listing comes before the nothing. So I'll select this. If I select this now, the next point of corner is if I should click OK, as I said last week, the point will be displayed on the screen. So I have to ensure that this is checked. Add point to point group is checked. If this is checked, the next point of call, again, if I should click OK, it will be displayed on the screen. So I have to ensure that I have to create a point group, just like you're working in an AutoCAD interface and you're creating layers for each of your drawings you are working, maybe your beam layer, column layer, slab layer, and all. So you can actually switch them and off them. So that's what this one does as well. So if I should create the layer now, I can actually switch the points off and on. So I will select this now, and I'll come here and I'll give the point group a name. TROD2 all points. So I'll click OK. Once I'm done with this, I can now click OK. Once I click OK, now the next point of corner, the point is not being displayed on the screen. I will do a zoom extend command in AutoCAD. That zoom extend is I can do a zoom extend, and I can just type Z on my screen, Z. I'll press enter key, and I'll type E. enter key. So the point now will not be displayed on my screen. The point now will now be displayed on the screen. So for me now, the next point of corner is, if you watch this point now, you can see the points that are a bit clumsy, that is not, the clarity is not being shown clearly. So we'll now do what they call this, what is stated on this slide. They say point appearance is controlled using point label and point style. So the appearance of my point now will be controlled using my point label and my point style. So I will go back to interface now. So to control the point now, I will just select one of the points. If I select one of the points like this now, watch what is happening. Watch this, my ribbon here on my home tab. If I select it now, we change. What it changes is showing that these entities, these items showing here now are all the properties that are assigned to these points that you can use to modify your points, work on your points, edit your point, and or give it different coloration. So you can use the whole of these entities here, work on it. If I press escape command, I take escape key, take me back to the initial interface on my home tab. But once I select the point now, all the whole entities that are assigned to these points, all the the properties assigned to the point will be displayed here. So I can use any of these tools here to modify my point. From here, all these tools are like this, I can use them to modify my point. So in Civil 3D, if you're working on point, surface, alignment, once you select them, to give you the pop-up, all the properties that are assigned to that element you're working on. For this one now, as I selected a point now, then I'll now go to point group properties here. So I'll go to point group properties. I'll go to point group properties here. So my point group properties now, based on what was stated on this slide here, on this my slide here, is showing that points appearance is controlled using point labels and point styles. So minimize now. So you can see now default styles. We have point style and point label style. So these two things are the things that control the appearance of my points. So the next point of call now, I will now go to, there's a box that has a pencil sign attached to it, or I'll come to this drop down arrow here. I'll select it and go to edit current selection. So once I click on edit current selection now, it will take me to a dialog box like this. So if you're using it for the first time, you're going to take you to information like this. So you come to the next tab and click marker. Select marker. So once you're on the markers tab, so you can come here and control the text height of your point. Like this is 2.5. So I can make this now maybe 0.5. And I cannot give it a marker style if I decide to give it. I can give it a constant marker style like this. So you can see the appearance is being displayed here now. So I take it to 1 now. You can see the appearance displaying here, showing the points, the marker style. I'll make it 0.8. You can see it's displaying here. So once I'm done, I'll just click apply. And okay, I've done that for the point style now. So the next one, I'll go to the point label style now. So on the point label style, I'll still select the drop down arrow here. Then I'll click on edit current selection. Edit current selection. So once I go to the edit current selection again now, then I can now go to take you to the, I'll take you to information like this. So you go to the next, to the third tab here and click on layout. So once you select layout, from that layout now, we'll come to this place that will have component name. So this component name now will have 3 entities on that component name, which are on this tab here. So once I click the drop down arrow here now, I have point description, point number, and point elevation. So this point description now is the first one you're seeing here. So I'll go to the text height now and effect it to be as well as 0.8. Watch it will be displayed here. See it now, this random it has gone down. So if Once I'm done, when I'm done with the point description now, which I've effected the test height, I've used it from 2.5 0.8. I'll go back to this component name here and go to point number, the next one underneath it here now. Point number, I'll make it as well 0.8. Then I'll go to the last one here, which is point elevation. And I'll make it as well 0.8. So once I'm done now, I'll just click apply. You can see the effect now. And okay. And I'll click apply and okay. So the point now will now be displayed. You can now see the points, the survey of establishment site. So the point now will now be displayed, showing the points he picked on. So you can see he picked 1, 2, 3, 4, 5 points along the row. Then it goes down like this. He picks, continues. So you can see the first identity here, fence. So this is the point number, elevation, and the description. So that will be displayed on the survey data. The point number, the elevation, and the description. So that's how it picks and go. So for me now, we imported, how would I call it, the whole data now. So if peradventure you are working on the data that the surveyor did proper description and he established a proposed center line for that road, like as he's speaking his point, let's say along the road he picks 18 5 points to the left, 5 points to the other, is 10 points and goes down like that. So at the midpoint, they're going to take that point as the center, as the CL of the road, and we go like that, establishing a proposed center line. The surveyor will have a proposed center line of the road, but you, the designer, the highway designer, will not give them the actual center line of that road. Once you are done with the design, you will now establish the actual center line that they use to go and carry out the setting out of the road. So how do we go about that now? Like this our survey data that is here now. This guy. This. Okay. So this is a data, and this is like a, how would I call it? This is a data now the surveyor sent to us now. I've done the first importation, which covers the whole data he established on site. I've imported the first data. So now I want to import the center line alone data to that same data I'm having. And I want to import the building line data alone, electric pole, the description he established on site. I want to import them individually. So what will I do? I will select the whole data, say Control A. Then I'll go to a tool in Excel. They call it sort and filter in Excel. So you see the tool here now. It's called sort and filter in Excel. So once I click on it now, then I'll select the filter, the filter icon there. So once I click on it, on my first row, it will go to there's a drop down arrow attached to them. So I will go to the last entity on the last column, which is for the description. So I will select it like this. So once I'm done with this, I will now unselect all. So once I unselect all, so I will now pick the actual data, the actual points I want to import into the software. So I'll select, let's say this is the CL he established. I'll select CL1. I'll select the whole center line he established on site. I'll select the whole center line data. So I'll click OK. So now the center line data does not fit out the center line data and hid. The rest data has now been hidden. So what will I do now? If peradventure I want to save this work now and import it into the software, and I saved it on this particular Excel workbook, it's going to still import the whole data because the whole data are still on this workbook, but I just hit them. So what I'll do now, I will ensure that this particular data, I copy it to a new Excel workbook again. So I'll say Control C, then I'll Control N, then I'll Control V. So now this particular workbook now now only contains the CA data, the center line data. So I will now go to file again now. So I will now do save. I will now save as again. Then I will save as on my desktop. Then my save as type will what? CSV comma delimited as well. Then this now, I will now name this one now. CROD to CL data. So I will now click save. So once I'm done, I will now close this. If I'm done with the next point of corner, I will now go to my workbook. So I will now import the center line data on this same data I'm having here now. So I will go back to point, just repeat the same process for point importation. Then I'll go to import and export points. Then I'll click on import points. Or I can still use this one as well. Like I said the other day. I'll go to point creation to import points. Or I can still use this guy here as well. Point, right click, create, import points. So any of them are common, you can use any of them. So I'll select this now. I'll click on add files. Then I'll go to where my data is being saved. You can see it's a TR2CL data. I'll select this, then I'll click open. Once I click open, I will now come to this point here now. I will now select the format that matches with the what I'm importing. So I'll select this pen Z. So I will now add point to point group. So I will now add point to point group. So this time around now, you can see the initial point group I created. The name is being displayed here. So I will come again and create another point group for this particular one now. So I will now come here and now select this box again. Then I will now come and type the name CRDCL center line data. So I will click OK. Once I click OK, I will now click OK. It should now bring up a dialog box showing that the duplicate point has been detected. Please select option below to resolve complete. I will click OK. So I have now imported the first one, the whole data is well, the whole data on the corridor he established. Then I now filtered and import the CL. So how will I to make that center line to be displayed? That's when now the process this in AutoCAD, how we switch our layers off and on in AutoCAD. Now we'll not display that same, we'll not carry the same process in this point as well. So when I come to my point now, you can see now on my point group, let me close this. On my point group now, if I show on my point group here now, if I should expand this my point group here, you see I'm having two names here. I'm having TRCL data and TR2 up. This is the first point I imported, which is the all data. And this one is the center line data. So I want to switch off now the whole data now to make the center line data to be visible. So what I will do, I will right click here, then I will go to properties. So once I'm on properties now, so on my point style and point label style, you can see this is showing basic here. This is showing points, elevation, and description. So to switch them off now, I will change from basic to none. Then my point label style, I will change it as well from point, elevation, and description to none. So once I'm done, I'll click apply. And okay. So to just show me the center line. So with this center line here, established on site now, I can now use this to actually do the design for horizontal alignments and come out with the proposed center line of the road. So this the center line now display. So this thing that I repeated now, this thing I just did now, you can do it for all. You can filter your electric poles. If you have an electrical along the road, existing road, you know that post is being located. So you show them in your drawing. You have building. You should so on your finished drawing that will come out like this. Before, let me show you something. I'm coming. Let me see something. I'm coming. Let me just show you. That will come out something like this. So you can see in the finished drawing now. So all these points you are seeing now are building points. So what we did, once we fit out, we'll have the point location. So we'll just do a legend and show the building location. When you have electric pole, you just put there and show the electric pole's location as well. So that's why the sort and filter is very important as well. So you can just highlight those points where they are located in the drawing and show it. So someone picking the drawing will know that, okay, there's a building here, there's an electric pole here, there's a river crossing here, there's a culvert here, and also, so you just show them on your drawing as well. So once you're done. So to bring back the point now, the whole data point now, what will I do? I will just come to this plane, I'll right click back, I'll go to properties as well. Then on this place that is showing none, I'll take it back to basic, the way it were before. And now with point label, I'll take it to point, elevation, and description. So I'll click on this, and I'll click apply, and okay. So the point will now displayed back on the screen. So these are all the intrigues and all the techniques you can use when you're importing your points into the software. So this is all it for point importation. So just like I stated initially, the first thing is where it gives you your points, notes the easting and the nothing, which one comes first. Then know the format. Then after you're done with that, then you save the work in the CSV comma delimited. If the surveyor didn't save, but most surveyors nowadays they normally send a CSV file to you when they extract it from the differential GPS. So after that now, you now import the point. So before importing your point, just like I highlighted, you take note of whether the point is having a header. If you're having a header, you delete the header. You take note of if there's any by mistake, by paraventure, when he was inputting the data, he puts a comma sign instead of a dot sign. You take note of that as well. And when importing, you ensure that all your Excel workbook are closed. So once you are done importing the points now, and everything comes out well, the next point of call is now to create the surface for the road design, which is the next slide that will be displayed here now. So this surface are the most basic and necessary element for any project. Surface is a must before creating any road or pipe network. So that's like what we've been doing since for the past weeks. Basically, what they give you an estate road to design now. An estate road to carry out the design of an estate road. So what the surveyor will do now, the surveyor will go to site, will establish the boundary of those estates and do a detailed topographic survey of the area. So the town planners and co would have done their layout for the estate and plan their road network and all, and where the buildings will be situated. So once you have established that now, so you now import your points, then the layout, you now use the layout as superimposed on the drawing that you're working on. So from there now, you now create a surface for the particular estate. So what are surface? In any project you are doing, you only have one surface for the project, but you can have different pipe network, different alignment road network, different any infra works you are doing. You can have different network, but for that particular entity, you have one surface for all. You can't have two surfaces in any project you are doing. So you have one surface for all. So that surface, what that surface entails is the area the surveyor covered when he goes to site to carry out his detailed topographic survey. So the surface will build around the TBMs, the temporary benchmark established on site. So the surface will build around that area. So if I'm doing a road now, like say, for coming to Abuja, like the whole of Use now. Let's say I should design the whole of Use. I will have one surface for the whole of Use, but I can have different alignments, different road network. So that's how it works. So for surface, so to create surface, we click Home tab, create ground data panel, surface menu, create surface. So it's the same approach as well. So we'll go into the software now. So to create a surface now, I'll be looking for the entity as well named surface. You can see I have one surface here, one. I have another surface here, two. And have another one here, three. So the first time, if I should click on this now, you can see create surface. You can see create surface. This is the first one. This is the first one. The first one is from my menu bar. You can see surface here. If I should select it, create surface. It's the first one. The second one is this. On my home tab, on my create ground data panel. You can see surface here. Create surface as well. It takes me there. And the last one is on my two space. You can see surface here. You right click and say create surface. So those are the three approach. Just like how we did for points. You can use in creating your surface. So if we make use of the one that are the two space. So if I say click here now, I right click and say create surface. So see what you're showing me now, what comes up here. Information, name, description, styles, contours, and render materials. So the first thing I'll do now, I'll just give my surface a name. Like now, if you're working on a project now, let's say you're working on the project in Abuja or anywhere, you just name it this surface, Uber surface, J surface, say surface. You just give it a name that you're almost done with. We'll say EG surface, existing ground surface. So from here now, I'm not changing anything. I'll just click OK. Once I click OK, watch what happens. The box has been attached to the surface. So the next point of call now, I will now expand this surface, this box attached to the surface. I will expand it. You can see the name, give it to it that existing ground surface 1. Existing ground surface 1. This the name created now. So the next point of corner, I will now expand this surface. This surface created here now as well. I will expand this surface. So now I now have marks, watershed, and definition. If I'm done with this, the next point of corner, I will now go to definition. I will expand the definition. So the next one, I'm having boundaries, break lines, contours, dem files, drawing objects, edit, point groups, point files, point group, points of queries, and figures of queries. So my point of emphasis of expanding those boxes, and I'm looking, my point of target is to look for the entity point group. So I'm looking for the name entity now, point group. So this point group now is when I will not select the point group. I'll not right click and I say add. Once I click on add now, I'll now look for, how will I call it, the point group now to create my surface. But meanwhile, this is another point that we should take note. When creating the surface, regardless of the data you've imported, like you have imported multiple data, the ones you filtered, imported center line, building location, electric pole location, I've imported all the whole data on my area. But once you are creating your surface, the point group you have to select is the first one you import, which has all the whole data encompassing it. So that is the one we're looking at for, not the filter data was created. So when creating my software now, I'll select the whole data, which is this one, the first point I imported, which is this. I'll select this now, and I'll click apply and okay. So the surface now will now be created. Along the entire area the surveyor covered. So you can see these extensions now. These ones are seen here now. These are the TBM locations, temporary benchmark establishment sites. So this now is the surface created for a particular project. So if I'm working now, any work I'm doing outside the surface now, we're showing that there's no data that captured on this whole area. So my work will be restricted inside the surface. So now another question may ask now, why is this contour lines? Why are they not showing those two? So there's a way you can actually make your contour lines to be more, to be displayed more. So if you select the surface, then you go to surface properties here and select surface properties. So on the surface property, if we go to surface style here now, you can see our contours, the default that comes is showing at every 2 meter and 10 meter in background. At every 10 meters, you create a 2 meter contour interval for you. That's what this one means. So you can actually create yours if you want to make the contours more, so that you can actually see how the land is how the undulation of how the land is looking like. So if you click on this box and there's this one, or you come to this side and say edit current selection as well. So you can see that if you take it to this point, it will have information. You can see the information is showing 2 meter and 10 meter background. So you see the next one is border. So this one, the next one is contours. So on these contours now, we can actually come to our contour intervals here. You can see contour range, 3D geometry, legend, contour interval, contour dispersion, and contour splitting. So on this now, we can select this. Now, you can select this now, then we'll go to basic elevation, which is at 0. The minor interval, you can reduce yours. Let's say this is, want to make it at 0.2. So watch now what will be displayed here now. So at every 0.2 and 1 meter, to create a contour line for me at every 1 meter, to create a contour line at 0.2 meter interval. So once I click apply and okay now, then I click apply and okay, you see the contours now that will be displayed more on the screen. So what I did, I came to surface. I went to surface properties here. And I went to this drop down arrow, selected edit current selection. And I went to contours here. And I went to contour interval. And from here now, I can now play with my contours and make the interval I want it to be displayed. I'm on this one now 0.5. To do the calculation automatic itself. What the minor I want it to be 0.5, the major to be at the major will be calculated automatically. You can see it's at 2.5 now. Once I click apply and okay, then apply and okay, you can see the contours now have not been reduced. So basically, this is how you create your surface in any project you're working on. So these ones are seeing your boundaries, break lines, contour, dem files. This dem file is digital elevation model. There's a way you can create it. If paraventure you are doing a preliminary design now for a client that that says just want to get an estimate of how the road is looking like, and the surveyor is not on ground to go to the site and do the digital working survey, and you want to, what would I call it? You want to just draw a rough sketch of to produce a payment so the client can have an idea of the cost of how the job will look like. So there's a way you can also go to Google Earth, you trace the path of the road. From there, you carry the file, you import the file into either ArcGIS or Global Mapper. From there, you can create a dem file From there, you can import the surface using a dem file and then just start the road design. That one is done for preliminary just listing, but in real sense, the surveyor needs to go to the site and do a detailed topographic survey. Because if you trace with cohort and all and do it, you can't have the actual elevation of the road. Once you go for setting out, there will be errors in your cut and fill. So basically, this is how you create your surface. So from here, the next point of corner is we'll now take out, because once we want to create our alignment, now I don't need the surface. What I need as a guide is the boundary of the surface. So I'll select the surface now. I'll go back to this point here now. I'll say surface properties. So on this, my surface style now, I'll come to this side and change it to border only. I need only the border to guide me when I'm doing my alignment. So I'll select the border, and I'll click apply, and okay. So to now give me the border, that is the border like this. So what I need the border is that if I'm doing my alignment now, this border will guide me that I should not go outside the border. But once I go outside the border, on my profile, it's going to affect my profile, showing that I don't profile now. The elevation value will not be showing blank. It will show blank because there is no data. So we didn't capture any data outside the border that I'm working on. So the next point of corner is now creating our alignment. So this alignment now. So the next point of course is alignment. So what's the alignment? Alignment are basically the series of coordinate lines, curve, used to represent the center line of roads, sidewalk. Alignment can be used to represent the center line of a channel or a stream. So to create alignment, click on Home tab, create design panel, alignment menu bar, alignment creation tool. So this is the same thing. Like last week, I shared some materials on the platform that I shared these materials you guys on that platform. So these materials, at least if you can go through them stage by, you can see it's well detailed. You can go through them stage by stage. I believe it will guide you as well when you're practicing. It's well detailed. You can see all this I'm saying, they're all highlighted here on the material. So the points, repetition, all displayed. So they're all displayed on. As you can see, the next one is alignment now. So they're all displayed on this manual that I checked last week that we created. So alignment now, we're on alignment now. Alignment is basically, how would I call it, a series of coordinate lines curved to represent the center line of a road, sidewalk. Alignment can be used to represent the center line of a channel or a stream. So this is where the actual design now starts. The horizontal alignment of the road now. So just like I stated last week, before I proceed into do this alignment, I have to check for what the type of road class I'm designing for. Is it rural road, a federal road, or a local road? So I will check and ensure that if I'm doing my alignments, all those criteria will meet the design standards stated in the Federal Highway Manual, be it for the super elevation, the curves, the how would I call it, the tangents, and all. So this alignment now, what entails is that when you do alignment now, let me just share this slide so that we'll read through it. can see now, they say the principles of horizontal alignment are summarized below. Tangent, that's a straight section of a road, should be as long as possible because the shortest distance between 2 points is a connecting straight line. Terrain condition, however, suddenly permit the connection of a road between 2 points in one tangent. Therefore, an engineer should make each tangent as long as possible. 1, if you are doing horizontal alignment, limit the number of curves on the road. 2, provide long side stretch, thereby improving the road capacity. So that your long distance, that the person social distance should be in, how would I call it, in consideration of, it should be into consideration when you are doing the horizontal alignment as well. So try as much about to make a tangent. Your tangent should be straight, it should be as straight as possible. Limit the number of curves on that road. Then provide straight stretches. But if the terrain, if the terrain where the road is being located have multiple curves, you design it like that. You put those curves, but now you now do what they call traffic TSMD, traffic system management drawing. There, your road signages and all speed bumps and all will be now introduced on the road to guide the route the drivers will be cognizant that there are multiple curves on the road. The next one, make the curves as gentle as possible. Long, gentle curves increase the capacity of a road by permitting high speed. This will provide a safe path of travel for the vehicle. Making gentle horizontal curves will increase the curve length, thereby decreasing the tangent length. However, this reduction in tangent length is minor compared to the benefit gained by reducing the total number of curves. What he's saying that you make your curves as gentle as possible. Like if I'm designing for a road, say a road of 60 km per hour, and I'm designing for a road using 60 km per hour, it's for elevation of 6%. I'm not expected to go below a curve radius of 123 meters in the highway manual. So if I'm going below that, I've go contrary to what I'm designing for. The radius is now lower compared to the minimum stated, which is 123. That if I'm taking a vehicle, if I'm driving at the speed of 60 km per hour and I'm approaching that curve, I should be able to navigate that curve with 60 km per hour. But if, peradventure, the radius of my curve is below 123, due to some conditions on the road or the route of the road, or some having built up area by the side of the road, and I decide to close the curve to avoid demolitions of some built up area and all. So I want to introduce what they call TSMD at that particular road. So at that before and after the curve, like I think 80 meters before the curve and after the curve, I will now put my road signage. The road is designed with 60, but at that point, the driver should be confident that their speed should be reduced to maybe 40, based on the design speed that based on the radius I got, and I will now relate it to the design speed on the code. I will now put that signage. If eventually the design speed for that particular curve is 40 km per hour, I will not input 40, that will step it down by 10 and put 30 km per hour on that road before they approach the curve. So these are the criteria. The next one, tangent should intersect other roads and railways at right angles. So if I'm having what do you call it, an intersection on the road, the intersection should be at right angle, hitting it at an angle of 90 degrees, not at an angle of 60 or not. It should be at an angle of 90 degrees. Operating efficiency is usually improved when this intersection approaches right angle. So these are the elements of vertical curve we've stated. All these now we'll see them, the PC, PT, PI, and length of chord and all. So this is what we want to do, we input in now. So based on the federal human one now, there's a way you can still check it in Civil 3. There's an entity called Design Criteria Editor, DES, Design Criteria Editor. So this Design Criteria Editor is going to guide you. So if I select it now, Design Criteria Editor. So I'll go to alignment here. So on this alignment now, you can see my minimum radius table. So for this minimum radius table, you can see the various elevation we're having there. So if you are designing for a road based on the federal highway, what do they call them? Let me look for it. Let me look for. Let me look for this validation. That's this validation aspect. Let me look for this validation. For this validation. It's not this validation table. That's what I'm looking for. So you can see recommended superelevation, this part of our word. So for rural roads, the maximum you should be having looking at is 6%, between 5 to 6%. So if for elevation you're doing all this ramp, rural access and multiplication project, they expect you to use a maximum superelevation of 6% for the road design, between 5 to 6%. For high-speed urban roads, between 4% to 6%. So based on the code as suggested. Then for minor urban roads, between 2% to 4% is for elevation. So if for adventure now I'm designing for a rural road now, and I come to this is my design criteria editor, I'm designing for 6%. As you click this now, watch, you can see the parameters here showed on this screen here now. So for 15 km per hour, I'm expected to have the minimum radius of 4 meters. For 20, 18. For 30, 21. For 40, 43. For 50, 79. For 60, 123. For 70, 184. For 80, 252. For 90, 80. So, but based on the federal highway model, they specify for rural road, the minimum design speed you can have is 60 km per hour. But driving on a rural road, you can drive above 60 km per hour. So they expect you to, the minimum radius you can have is 123. That minimum is that you can go above that if you have a wider land, a virgin land, you have a wider radius, but the minimum radius should be 60, should be 123 for 60 km per hour using super elevation of 6%. If we go for this now, see this one, 4%, you can see them as well. 4% now is 135, 50, 60, this 40, 8. So this will now guide you as well when you are doing the horizontal alignment, when you are done for the horizontal alignment. So you can see for 8%, you can see for 100 km per hour is what? 394 minimum radius there. For 10%, 358, 12%, 328. For this, for 6% now you can see it, 437. Most of these are federal roads. Mostly they use 6% for elevation for the design. 6 to 4%. 4%, 492. So this now, when I guide us when we have a curve now, we're designing, okay, at this particular curve, we know that the minimum we're having there is 60, for 60, 123, 100, 492. If we have a wider land, but if the land is a bit closer and have a bit of area there, you can close the curve. But once I'm done designing now, you now input what they call, how will I call it now? You now put the signage. Let me just show you something like this. You come out like this. For this drawing. Come out like this. Let me look for this. To come out like this. can see this now. So on the drawing now, you put a TSM drawing at that particular location, meaning that the curve is not meeting the required criteria. So the TSM drawing will produce before and after the curve, before you enter the curve and after and when you enter and when you are navigating, going out from the curve. So basically that's how you go. So for the alignment now, for alignment, to start alignment now, based on those principles I just read now, the first thing you're looking at is what? Tangent should be as long as possible. So your tangent, the road should be as long as possible. And if you're designing a road as a road designer and there's no curve on that road, it doesn't sound, how would I call it? It doesn't look good as a road designer. Imagine you flying from here to, how would I call it, from here to Kaduna. You're driving and there's no curve on that road. It doesn't speak well as for a good road designer. You must try as possible to at least create imaginary curves on that road. Why are you doing that? Because if you are driving, if you have no curve on it and the driver is driving, those drivers sometimes some of them might just slip off on the road. But once they have curve, they will know that at some point there's a curve at that point to be visible when they are driving. But if the road is as straight as possible, going straight, some of them might slip up on the steering. So it's always possible to have curves on our road as well. Have curves, but let the curves go at a longer distance. At least. So to carry the alignment now. Let me demonstrate now. So these are my survey points now. So alignment now, if I want to do my alignment based on this our slide we have here now. This alignment, to create alignment, click Home tab, create design panel, alignment menu bar, alignment creation tool. So what you're saying, if you go to Home tab here, we'll go to create design panel, which is this panel you're seeing here. Then we'll go to alignment here. Then we'll click on alignment creation tool. So from here now, we'll now create our alignment now. We'll create our alignment. So if I click OK now, to display this for me, alignment layer tools showing. Then I'll go to the first icon here. Then I'll select target no curve. Target with curves. What it means is that this one, you should just take it as a straight tangent. But this one, I know having a curve, you're going to put a curve for me automatically. So if I should click target with curves now, then I want to just display this one outside on the screen. I click like this. I go, and I click, and I hit enter. So what it does is that it has repeated. I'm clicking and I'm dropping it. It has repeated what the curve for me itself automatically. Using this first method I just displayed here now. So this first method, there's no leverage for you that you can play, edit, or shape your alignment to come up perfectly well. So mostly, I don't normally recommend this first method for beginners that are doing design. I recommend for them to use the line, trace, use a normal line, draw across the alignment you are going, draw across a part of the alignment, draw. Then if you are done, when you have a curve, you leave it blank, draw. Then once you are done with getting the straight tangents, then you come, use an extend tool, extend them together, join them together, join. If you are done with that, then you now use a polyline, trace across the line to make them one entity, or you convert the line to a polyline using a p-edit command in AutoCAD. Convert a line to a polyline all. So once you convert a line to a polyline, then you can now convert that line to an alignment. So from there now, to now give you a leverage, then you can play, edit, shape your line, and do all sorts of the alignment. So I don't normally recommend this automatic method for beginners. I don't normally recommend it for beginners. So the method I adopt is, don't use our line, trace, take your line, go across the part, then get your alignment. So I will display that method now on the screen. So I will delete this. So in doing the alignment now, just like I said initially, we've imported 2 point groups, which is displayed. They will have this, the all points, and the center line. So in creating an alignment now, since the surveyor has established a proposed center line for us on site, I would also use a center line. The center line will now enable me to, will now guide me in doing my alignment. The center line will now guide me when I'm carrying out my proposed alignment for the road. So how will I do now? I will come to this order now. I will right click. I will select properties here now. Then I will come to basic. I'll take this guy none. I'll make this guy none. Then I'll click apply and okay. So I will just be left with the center line of the road, which the surveyor established on site. The proposed center line established on site. So this center line now will not aid me faster when I intend to do my proposed center line, the alignment of the road. So start the alignment now, just like I stated earlier on. I'll pick my line. Hope we all know the difference. This is a line now. If I should click like this, like this, like this. So what it means is this a line now. It sees them as different entity. For a polyline, sees this line as what? Sees the object as one entity. So first thing, I can just try to create a layer properties and just create a polyline or work on the same layer properties. So I'll pick my line. I'll select the line. So I will now go to this point. This point is being called Kogo point on this software. Kogo point. So I'll select one of the points. And I will now go using a line. I will draw. See, I picked my line and I just traced. I dropped this line here on the screen. So once you see the route, how the route, the path the surveyor follow, you'll be able to identify where you have curves on that road. So when starting the alignment, you can also pick your cycle and highlight those locations where you have what do they call it, curves that are that the proposed curve the surveyor establish how the road is undulating and all. When he picked his topographical survey on the site, his data from the site. So for me now, I'll just drop this now. And now that's the next port of curve. If you're looking at this data now, you see that this guy goes like this. And I see there's a small curve here that takes this guy downward like this. So I will now pick this other one now. And I will now go. I will now drop this guy to here like this. So watch what I was doing. I click the first one and the other one. I know that at this junction here, it will likely be a little curve at this junction here, based on how the terrain goes. That's why when the surveyor goes to the sites, when you go to site for a reconnaissance survey or how will I call it, for a detailed topographical survey, it's always good an engineer is with them and they will establish those areas that will have critical curves on the road. You can pick the coordinate and all where you have critical curves that you can't avoid on the road, that it must be a curve here, it must be a curve here, it must be a curve. So that will not as well aid you and guide you when you are doing the horizontal alignment of the road. So you know you have those critical curves that you can't avoid, that you put them on the road. So for me now, what I did, I pick my line and I draw straight. Because when I go to survey on the site, I know that at this place, this is a straight alignment. But once the surveyor is picking this instrument and they are working, dropping the tripod stand on the road, they can't have a straight alignment because the point cannot go zigzags. But I know that's a straight tangent, being that there's no obstruction, it's a clear path and all. I'll just take it perfectly straight. If for eventually I'm taking my line now and someone will ask, why is it I'm not tracing this line individually like this? But I come, I do like this. I click, I click, I click, I click, and I click again. What this does is that if I'm done with this now, and I try to convert this line to alignment, the software will see those 2 points of connection and try to put a curve for me there. Those 2 points of tangent, this like this line and this line. We try to put a curve for me here. Try to put a curve for me here as well. And based on what I said earlier on, it's always good to avoid short curves on the road. Let the curve be as far as possible. So if I should click this, click, I'm putting multiple curves on my road. So the principle that we adopt when we are doing our road design is the same principle that, how would I call it? Those days we normally do, what do they call this in school? Quadratic equation line graph or simultaneous equation line graph. That graph will do line of best fit. Line of best fit, as if you're having 2 or 3 points that cut across the line and you have the state that you are fine with it. Doesn't mean you have to follow what the center line is the surveyor established on site. So you the designer now, you're not designing based on I want to have a straight tangent, a curve, based on your passing side distance, stopping side distance, and all. We'll be taking that into consideration that if I'm driving now, I'm able to see the longer distance before I navigate back on the road. The longer distance, at least 600 meters or minimum 400 meters before I overtake a. And before I do my passing side, I overtake a vehicle coming. Overtake a vehicle. So those are the things you'll be putting into consideration when you are doing the total alignment of the road. So that's why I see when I pick my first line, I pick this and I draw. I just look for a best fit. I drop. So I can now say, okay, at this point, I see there's a curve that takes this road. It's minor curve. I take this road downward. So I will now pick another line again now. And I see that, see the way this way goes like this, and this is a straight road. I'll just pick, this is where this line is intersecting this guy. I'll just pick again. And I will go. Say straight road. Why would I put multiple curves here? I'll go back. Let me just put this here. I'll put it here. This is now the straight. So you can see most of the curves, the line didn't touch most of the curve, but at least 1, 2 is once it passes on the line 1, 2, you're okay with it. You just plot your line like that and go. Then you go to the next. You're having like a longer stretch. You do them individually to get the road alignment perfectly well. So if you're done with this now, the next put of call, I'll now do my extend command. Normal extend in AutoCAD or extend this guy to hit this guy. So the next point, I'll now do a trim command. So I will trim. Then this is where my road terminates. So I will not trim this guy off. If I'm done with this now, the next point of call now is now where that entity now comes into play. We'll now know the function, the difference between a line and a pulley line. If you're using a line, at a certain meter where the line breaks, it sees the lines as different, or like a different segment of lines. If you're using a pulley line, once you click one and go straight, you see them as one entity. You see them as an entity. So that's the same principle applies in road design. If parameter, if I want to convert this line now to an alignment now, and I click and click, parameter, it might not go through the entire stretch of the road. Some where we have those breakages and it's not intersecting well, you see the element will stop at that point. That's why it's always advisable. Once you are done using your line to get the alignment, the next point of call, you can now use a pulley line to trace across the line you've drawn. So imagine I'm having these lines now, like 100 of them now. So how will I be able to know where these lines are intersecting? That's why now you now select them individually like this. You select like this, you right click, you go to properties, and you can give them different coloration. So this different coloration I'm attaching to a line will guide me when I just pick my plane and I will now be snapping at that point where they intersect. So once I have this different coloration now, imagine I'm having this line multiple, like something like this. Something like this now. So once I give this guy a different coloration now, So for me to know the other one, I would also do a match property command. Match property, or match this guy and this guy. Because I will match them. So once I'm done matching them like this now, I will now pick a poly line. It does get me faster. I'll select this. Go. So it'll be faster for me to trace across the line. So that's the same principle I want to adopt here as well. So once we're done with the next point of corner, we'll now pick a poly line and now trace across this line. True. I'll trace this line. Go here. Now trace to the end. So I'm done with this. At this junction now, this is my point. I no longer. I'll now take the point off as well. I will now go back to the center line that I here on this point group. I'll select it. I'll right click. I'll go to properties and I'll take it off as well. I'll change from basic to none. I'll change my point label style from point elevation description to none as well. Then I'll click apply and OK. So if I'm done with this, the next point of corner, I'll now go to this alignment. Remember, the first one I did alignment creation to what was the automatic method of you create your alignment. Any click, drop, you click. There's no leverage for you to play around with it or edit it. But this one now, you can see this one we just did now. There's a leverage I can adjust my line, shift my line, extend, trim, extend, offset, do all things with the line, play with it and get it perfectly done where corner apply it and convert it to an alignment. So to do that one now, I'll go to this alignment here as well. And I'll go to create alignment from object. So this thing I'm not drawing down is an object. I'll select create alignment from object. So once I select this now, you ask me to select first line or arc / polyline. So you see the essence of course using a polyline. If it's one line selected now, if it's one single line, you have to go and select the line individually, clicking on them one. Or if you select a polyline, you select the whole line from the start to the end. You can see it's highlighted everything from me to the end. But if I use normal line to break them, I'll select them individually, one after the other. So that's always good to use a polyline when you're doing your road design. To use a line first, draw the line, then now trace with the line across the polyline. Or if possible, you can use a PEdit command and convert the line to a polyline in AutoCAD. Same principle. So for me now, if I'm done with this now, you can see I've not selected the line now. The next point of call, I will now press my enter key. So an arrow sign now will now be displayed. An arrow sign now will now be displayed. An arrow sign now will now be displayed. This arrow sign, what it's showing is that where will your chainage start from your 0, 0? If your road is starting from this point here now, you press enter to accept the alignment direction. But if you're starting from here, you click on reverse to reverse it and start the change from this point to this point here. So 0, 0 will start from here, 0, 0 will start from here, then you go and end here. But if your direction is okay by you, based on the roots of the route and the survey, put on the route the surveyor covered and you establish that this is where the road is starting from, then you now accept it to enter. And you press enter. I'll press enter to accept it. Let's assume the direction is starting from here. I'll now press enter to accept. So this now brings up the create alignment from object dialog box. So the create alignment object from dialog box. This now will now come and okay. We'll now give our alignment a name. Let's say this is this. We'll now give it a name. Say training TROD, like the project name I'm working on. Alignments. The type is center line. Give it a default. The next one now, you can see this tab here. We're on general tab. So on this general tab, we'll leave it at default first. Then we'll go to the design criteria. So this design criteria is where now we're now starting design speed of the road. So then you can now input your design speed of the road. If you're designing for 60 km, do is you put the design speed, then you say use design-based criteria, use criteria-based design for this. So if you click this, so you can see the codes here. So the minimum radius per elevation table, if I stated for rural road, is 6%. So once you include this now, so you have now restrained, how would I call it, the software now to be, if you're having anywhere, you're having a curve below that design speed, below the 6% per elevation, which is 123, and your design speed is going to show you a flag showing that there's an error there. Like how we do in structural software that something fails. You give a red sign that there's a failure zone, something has failed. The road will show you that particular, if you give an error sign that at this particular space, it's not between the design speed limit, the radius of the cover, no. You give that error sign, showing that there's something you need to do there and work on it as well. So for me now, you can as well just leave this and make this at least check. So from here, if you're done with this now, we'll now go back to general. You can say I've constrained myself to 60 km per hour. This is 6% per elevation. So based on that design criteria table I showed you earlier on, the software is going to pick that, use that table as a guide to checkmate my design now. So if I'm going below that radius stated in the manual, it's going to flag it off. It should give me an error sign that this is below the range of 0. So from here now, I will now go to general. For general now, you can see the next thing now, site, we'll leave it at none. Alignment style, leave it as proposed. Alignment layer, leave it as C, is a layer. Then alignment label set now. This is showing no labels. What it means is that if I should create my alignment now, this thing showing on my drawing, but it's not stated, I didn't open it. The labels won't be shown on there. That is the chain agent on my drawing. The chain age, the PC, point of tangent, point of curve, point of chord, all those things won't be displayed on my drawing. So I will now come to this new label and change it to major, minor, and geometry points. So I'll select this major, minor, and geometry points. So on this major, minor, and geometry points, the next point of color, I will now come to this drop-down arrow here. I'll select it and select edit current selection. So I'll select and edit current selection. So on this current selection now, you're using for the first time to take you to information. So I'll click on labels. So on these labels now, you can see the major, first one is major station, minor stations, and geometry points. So on the major stations now, this is showing parallel with tick. Okay. This major station is showing parallel with tick. The minor is showing tick. And geometry point is showing perpendicular with tick and line. What this thing means, this parallel with tick, now I'm going to change it from parallel with tick to perpendicular with tick. What it means is that this, if you have seen a typical road design drawing before, see how this labels is here. This show you perpendicular. But parallel means it should be like this, to be straight like this with the road. For most of our road designs, so they change it, it's supposed to be at parallel with the tick. That is this tick here. This is a tick sign here. So this is a tick here now. So I want the major stations to be parallel with the tick, not perpendicular, not straight with the tick, let it be parallel with the tick. So I'll come to this side here now. There's a box sign here. I'll select it, this particular entity here. I'll click on it. So it's taking me to pick a label style. So I'll come down here and choose perpendicular with the tick. So once I'm done now, on the increment, the major station should be at what? 100-meter interval, and the minor should be at what? 25-meter interval. This is the style of changing we use in this part of the world. 25-meter interval, but the major one should be at minor at a 100-meter interval. That's why I see them on, if you go to our major highways when they're doing the major project, you see them labeling that, you do that changing basically most times at 100-meter interval. 100, they write that change signage at this 100 change, 100, 200, 300. So the minor ones will be 25 meters. 25, 25, 50, 75, 100. If I'm done with this now, I will now click apply and OK. So you can see the default radius. This software is showing 200 here. I can leave it as default as like it is as well. I'll now click OK. It will now convert. You can see that it has not converted that line to an alignment for me now. So now this alignment now, then to check whether to check this my radius now, to check if it actually meets the criteria. If I mention now, I design this road and the radius is not meeting the criteria, at this point we have this point of intersection here. This and at this point here now, you go to give it like an arrow sign to pop up a message for you somewhere here, showing that the radius is below the required standard for the road. Either you go and increase it or you work on it as well. So to do that now, to check my radius now, if it actually meets the criteria, or if it check for that now, select the alignment like this now. I'll click on alignment, and I'll go to geometry editor. So if I click on geometry editor, then you can see, then I'll go to the last icon, this green one here that has a pencil. So I don't know, alignment grid view. You should look for the alignment grid view icon. Now if I click on the alignment grid view icon, so for me now I can now go, I will now see the radius parameters. So for me now, if I want to increase my radius or reduce my radius based on the bit of area I'm having close to it, I can use this. If I say 123 now, watch the screen out. It has reduced to 123 based on the minimum criteria stated. Let's go below 123 and see. Let me go 100. Oh, what happened? You can see that thing I was saying. It has given me, it has displayed a sign for me, showing that there's an error somewhere. See, minimum radius 123, current radius 100. So the minimum radius violated. You can see the error now showing me. So if peradventure there's a bit of area here now, I'm having building close by, I don't want to pay for compensation. I want to stick with this radius now. I will just leave the design like this. I'll say no problem. I will dismiss this error sign. But when I'm doing my final drawing presentation and all to the client, be the ministry or all and all, I explain to them that this bit up and they agree that they're going to pay for compensation, only demolition. And I was okay, let's just leave it like this. And I will now produce that drawing and display there on the TSM before and after the cover. I will now impute the radius, the speed limit that the drivers, imagine they're driving from here and they're coming at 60. Before they enter the road, I'll put somewhere here. Okay? They're approaching the curve or somewhere here. I'll put the signage here now. So let's just look. Let me check this with the criteria for this one now. It has 100 km per hour. I'm using 60 km per hour. So I'll come to design criteria editor and I'll check. Let's see the design speed that I will put the signage I'll put for that road. You can see, you can use this 50 km per hour. So I'm having 79 here. And I'm having 100 meters my radius. So I'll go for 50. So I'll put 50 before and after the, what do they call it? The curve. But for that 50 now, I know that it's 50 kilometers to go, but I'll go less than 50 and put 40. So if peradventure the driver, before the driver should accelerate to reduce to decelerate and it's approaching 50, you can still navigate. So I'll step it down by 10 kilometers. That's how it's been done for your traffic management system. If I design a road for 60, you step it down by 10. So that's what signage of the road. So to take it back to the initial listing, which was the what I was make this. I'll go back to this place and now and I include the radius. I think it was in 200. Just enter. So I show it as passed now. So the error sign will now be taken off from now will now go off. So from there now, if you're done with this now, note the surveyor. Let me display this to properties. This basic, this point elevation and description. So this is the points the proposed center line is surveyor established on site now. So this one we just draw now will be the actual center line of the road now will give to the surveyor the surveyor will use now to go and set out the road for us now. So how do we go about that now? So if I select this, let me just take this guy off again. Properties. This one known. This one known as well. I'll click apply. Okay. So now to display the actual center line of the road now. Let's say he wants to go to side down now and peg and set out the actual center of the road now. I'll go to this. See when prospectus toolbar here. So I will go to the toolbox to here. Then I'll go to report manager. Then I'll go to alignment. Then I'll go to incremental station report. So I will select and I'll now say execute. When I say execute, I'll now come here and put my station at 25-meter interval. I will now say create report. So this is the data now. The surveyor will use now to go and set it out the road for me. I will now send the surveyor this data now. We now use this data to go and set out the road, the eastern and the northern coordinate and go peg. See them pegging. We'll go and peg out the road will not come out on ground now. It will now be displayed like this. How you start from here, this curve will come out to go exactly like the way it's been drawn on the way it's been designed. If I'm done with this now, this is the center line of the road now. And let me say I've done my preliminary traffic study.
We lost your screen. We lost your screen.
Oh, so sorry. Oh. Okay, I don't worry. No worry.
This meeting is being recorded.
So sorry for that. It was internet.
I'm the screen word.
No, share screen. Hmm? Hmm? So sorry, I went off. I'm working on it now. Hello? Can you all see my screen now?
Yes, we can.
Yes,
Oh, sorry for you. So I have network downtime. Okay, so as I was saying, the one we just finished designing now, this is the center line now will now give to the surveyor, which the surveyor will now use to now go and set out the road. So to bring out the coordinate for the center line now, you go to your toolbox, one on perspective, tab by, then we'll go to the toolbox. Then we'll go to report manager here. Then we'll expand the report manager. Then we'll go to incremental station, select it. Then we'll right click and say execute. So on this execution now, so the station increment will change to 25 meter. And I will say create report. So this report now will now be sent to the surveyor. The surveyor will now use this data to set out the road. This is for the center line. So if we are done designing this now, the next point of corner is to create what they call alignment offset. So this alignment offset, as I was saying,
your screen has gone off, Engineer Victor. Your screen is not showing.
this network. What's happening? Still. Let me go with you again. Yes, I'll come with my seat. Yeah, this our
Hello, please, let's exercise patience. He's coming, he's trying to come online.
Okay, thank you.
Colleagues, I just have this to say. While we are still waiting for our tutor, it's like maybe next week is gonna be the last class, but for some of us that maybe conversant with Civil 3D, I want to assume that where we are going is very far. We might not be able to actually cover up everything that we are expecting to gain from this. So are we taking next week to be the last class, or we are requesting for extension? Thank you.
Next week, not the last class. We still have.
But there should be extension, no? With
Can you hear
this
me?
break in network off
Hello?
and on, I think there should be an extension.
Hello?
I think
Yes, sir.
Uche will come in, or
Yeah,
as Stephen is saying.
yeah, this is not the last. The next week will not be the last class. We still have 2 classes after today.
Oh, that would be great.
Yeah.
Oh, fantastic.
You cannot log in. Just calm down.
I think we really need to have all these materials sent to us. We can print them in hard copies to go through some of these are programs. Because if this class ends in the next 2 sections, I don't think we're going home with much personally.
Yeah, but I think the codes, they were actually, it has been sent to us last week, the highway codes and standards. But for this slide that is using, I'm not too sure, maybe we have it or not.
Hello, good afternoon, good morning.
The group, there are a lot of documents.
Can you hear me?
Yes, sir.
Please,
Sir.
let me start. Let me sincerely apologize. This network issue, it started last night. I'm supposed to have a meeting last night. The network was so bad. So apparently our resource person is in a very bad network area. So I crave your indulgence. Let's end the meeting. But next week we'll make it up. Next week, please, let's prepare to stretch a little bit more. And because Obio apparently cannot join again because of bad network. So please, I'll plead with us. Let us end the meeting, and I'll probably be available to also, participate fully. So please, sincere apology. Let us end the meeting now. I will send, just like I did last time, I'll send a video that was supposed to take care of what we're doing today. Please, this is an appeal, and I hope it's well received. Let us meet next week again, and We'll make it up. Thank you very much. So I'll end the meeting now,
That's
and we'll
fine.
meet
That's
next week,
fine.
please. Yes, please. We'll make it. We'll make it up, please.
Yeah,
We'll continue from where we stopped.
Mr. Engineer Uche, please don't forget to send the video, please.
I will send you the I have a video for cohort 2 and video for cohort 1. I'll look for day 2. This is our day 2. I'll look for the same
Okay.
video. In fact, I sent one yesterday, but I'll send another one. Yeah, if you go through the same thing, we are cohort 3. So 2 sets have already done this training. Thank you.
Okay. All right.
So I'm ending the meeting. Thank you.
Okay.
Thank you. Yeah, bye. See you guys next week, please.